All right, good morning, y'all. So today we're going to be talking about our different forms of quadratic equations. So last week we talked about the different key features, kind of our key vocabulary for quadratics. This week we're going to be talking about the different types of equations that you could run into. So there's three main types. That is our standard form, our vertex form, and our factored form. Okay, and each of these are going to be useful for showing us different key features that other ones aren't going to be able to show us. So first off, let's start with our standard form. So our standard form is y equals ax squared plus bx plus c. And that's really what you've seen so far, where we have that x squared at the front, we have an x term in the middle, and then we just have a number by itself at the end. So when it's in standard form, there's two key pieces that we can pull out. The first is our a value. Okay, a tells us whether it's going to open up or down. Specifically, if we have a positive A, then that means we're going to be opening up. And if we have a negative A, then that means we're going to be opening down. Okay. Now, the next key feature is C. So C, it's that number added to the end. It's always going to be the y-intercept. Okay, we see this a lot with functions, that the number added to the end is the y-intercept, and it's going to stay true here today. So whatever C is going to be our y-intercept. Nothing too tricky about that. C can be positive, C can be negative, it can be a fraction, a decimal. Doesn't really change anything. It's just going to change the y-intercept. Okay, so kind of going off an example. So if we have y is equal to 2x squared plus 4x minus 3. Then information we can pull out of here, a is equal to 2, which is positive, so it's going to open up. And c is equal to negative 3, so we'll have a y-intercept of 0, negative 3. Make sense so far? Okay, let's do one more. So if I have y is equal to negative x squared plus 3x plus 7. So once again, I go and I pull out a. So a is equal to that negative. Just being negative, there's another number there that we don't write. It's a negative 1. So that means it is negative 1. So since it is negative 1, it's a negative number. So we're going to open down instead. And then c, in this case being positive 7. So c is equal to 7, which means we're going to have a y-intercept of 0, 7. Okay, so standard form, two easiest things we can pull out of standard form is if it's going to open up or open down, and then the y-intercept. All right, so moving on along to vertex form. Now, we talked about this last time, that the vertex is that point that's at the bottom or at the top of our parabola. Okay, it's that point that everything kind of meets at. Okay, it is the vertex. That's what a vertex means, the meeting of two lines. Okay, so our vertex form, once again, we have A. A is up here in the front, and A means exactly the same thing. If it's going to open up, or if it's going to open down. And nothing changes about A. Positive A is still going to make it open up. Negative A is still going to make it open down. But we're adding a new piece, H and K. Okay. Now, H is going to serve two things. The first thing is that it's going to be the axis of symmetry. Oop, that went weird. Okay, so H is always going to be equal to our axis of symmetry. Now, the weird thing about it is because notice how we have x minus h. So notice I only took out the h. I didn't take out the negative h. So whatever that number is, so if it's like x minus 2, our axis of symmetry would be x is equal to positive 2. If it's x plus 3, our axis of symmetry would be negative 3. So our axis of symmetry is always the opposite sign of what's inside here with the h, which is a little bit weird to think about. Now the other piece we have is our k. And our k, if it will let me switch over, there we go. So k is equal to our max slash min value. So whatever k is, it's going to be our maximum or our minimum, just depending on where it is. And it's going to be a max or a minimum depending on if we open up or if we open down. So we kind of have to use a and k together to know if it's going to be a maximum or a minimum value. And then last but not least, we can use h and k because h comma k is equal to our vertex. And we talked about this last class, how whatever value the axis of symmetry is and whatever value the max or min value is, we can put those together to get our vertex, because our vertex is always going to go through the axis of symmetry, and then it's going to be on that highest point or that lowest point, so it's going to be where the vertex is. Okay, so let's look at an example. So if I have y is equal to 2 x plus 3 minus 4. Okay, so we have y is equal to 2 x plus 3 squared minus 4. So some things we can pull out. So our a value here is 2. So a is equal to positive 2, which means we are going to be opening up. Our h value here is negative 3. So notice, just like I said earlier, that I'm switching that sign of what's inside. So h is equal to negative 3. So our axis of symmetry is x is equal to negative 3. Then our k value down here at the end is negative 4. So k equals negative 4. And to know if it's a max or min, I have to think about which way it's opening. So since this one is opening up, okay, because see how it's going to have that minimum value down at the bottom of the U because it's opening up. So that means my min is equal to negative 4. And then last but not least, okay, I can put my axis of symmetry and my minimum value together to get my vertex. So our vertex is equal to negative 3 comma negative 4. All right. So just as a recap, our standard form, we can find which way it opens up or down, and we can find the y-intercept. Our vertex form, we can find which way it opens up or down, our axis of symmetry, our max min value, and our vertex. So nice and easy to remember, vertex form is used to find the vertex. Okay. Now, last but not least is our factored form. Now, we haven't talked about this before, but factors are what we use to find our zeros, our solutions, our roots, our x-intercepts. Remember those things that all have the same name or different names, but they're all basically the same thing. So that's what we use our factored form to find, is to find those zeros or to find those intercepts. Okay, so we have y is equal to a times x minus r1, which stands for root 1, or times x minus r2, standing for root 2. So once again, we still have that a value. So we've talked about this before. What does a tell us? A tells us which way it's going to open, up or down. Okay, then r1 stands for root / 0 / solution. And R2 also stands for our root / 0 / solution. Okay. So they're each two individual roots. Just like h, we're going to switch the value when we actually get it. Okay. So x minus R1 and x minus R2, just like for our h, we're going to switch the value when we actually solve it out. So let's look at an example. So if I have y equals negative x plus 2, x minus 1, then my a value is negative. So that means we're going to open down. And my roots are equal to negative 2 and positive 1 because we switched those signs around. And if we wrote them as actual points, as actual x-intercepts, they would be negative 2 comma 0 and 0, not 0 comma 1, sorry, 1 comma 0. Okay, let's do one more example with this one because we got some room. So we have y is equal to 3, x minus 4, x minus 7. Okay, so our a value is 3, which means we're going to open up. And then our roots are equal to positive 4 because we switched that negative 4 around, and positive 7. And if we wanted to write them as actual points, 4 comma 0 and 7 comma 0. Hey, so just as a recap on our three forms, standard form we use to find if it opens up or down, and then the y-intercept. Vertex form we use to see if it opens up or down, and then the vertex, which also gives us the axis symmetry and the maximum and minimum value. And then factored form we use to find if it opens up or down, and our roots, our zeros, our solutions, or essentially our x-intercepts. So all of them we can use to determine if it opens up or down. Okay, we can always see that a value. Each of them, though, gives us a different key feature. Standard form gives us y-intercept. Vertex form gives us the vertex, which we can then pull out the axis of symmetry and the max and min value. And then factored form gives us those roots, those solutions. Hey,